Try to keep us on almost on time,
Okay.
which is going to be something new that we're trying.
Yeah. Something brand new.
So I'll just open it up. I wanted to say welcome everybody to Skeptics in the virtual pub for 18th March 2020. This is a program of the Triangle Skeptics. And we're going to have a great speaker tonight, Joel Doc Kann, who's a member of the group, and an emergency and family practice physician with Duke Health here in the greater Raleigh-Durham area of North Carolina. He's going to talk to us about COVID-19 facts and misinformation. I've got just a few introductory slides since we've got some first timers and since this presentation will go online for all to view later. I just wanted to tell you a little bit about what our group is. First of all, we are glad that you're here. That's the most important thing to know about us. Thanks to all the first timers, all the newcomers, and anybody who may be watching this after it was recorded. We're also doing this for the first time online, so please bear with us as we iron out the kinks. Bob, I just forcefully muted you because I was getting a little back talk from you. Sorry, that's what I got to do. We are, as of the beginning of this month, March 2020, a North Carolina educational nonprofit. We're dedicated to promoting critical thinking and the scientific method. We think of ourselves as skeptics in the mold of Carl Sagan and James Randi, not skeptics in the sense of people who might identify as anti-vaxxers or flat earthers or climate science deniers. If you're somebody who self-identifies as one of those things, you know where the exits are. We're also glad you're here. If you're here, though, as one of those people who are normally at odds with us as skeptics and want to hear what we have to say, we also want to hear what you have to say generally. So thank you, regardless of who you are, for joining us. So without further ado, I want to get into our presentation tonight. The topic will be something like facts and misinformation around the current COVID-19 pandemic. I'll let Doc actually give the real title. Our speaker is, as I said, Joel Doc Kann. He's an emergency physician and I think also does family medicine here in the greater Raleigh-Durham area. And he has spent a lot of time in recent weeks in the social media trenches, both promoting facts and fighting COVID-19 misinformation. And he kind of, I think, 75% jokingly offered to give this talk at our last physical meetup in February. I doubt he makes that mistake again, but I thank him for stepping up so graciously and taking this so seriously. So Doc, I'm going to turn it over to you. Thank you so much. I'm going to stop presenting and I'm going to make you, if I can work out how to do that, I'll make you the host.
Whoops.
Okay.
Actually, I think I won't make you the host.
Yeah.
I'm going to spotlight your video. I think if I make you the host, it might cause problems with the time limit. Wow. So go ahead and share your presentation.
Well, just let me say welcome to everyone. We'll give you my way of greeting people now and say welcome. Let's see if I can get the slides up here. Let's see. Are people seeing it?
Yep.
Okay. Let's go to, can you see that?
Yep.
All right. So, you know, I'm going to make this pretty informal. Feel free to jump in with questions as we go and as they come up. So I did agree this, I think about a month ago. We were talking after our last meeting, and at that time, COVID-19 was in its early stages, hadn't really gotten to this country yet, and there was a lot of misinformation about it. And I said, oh, you know, I could talk to the group, and thinking that would be about a 10 to 15 minute talk, and that would cover everything. Little did I know how this was really going to explode. There's new information coming out several times a day. We have meetings I'm at Duke University in urgent care. We are changing protocols, we're changing testing, we're changing treatment, we are changing everything at least several times a day, having meetings. And I'm on a physicians group on Facebook now, physicians and COVID-19 sharing information and opinions. And everybody is just overwhelmed. You know, when I started, there were about 160 articles on PubMed, and there's now over 2,000 articles. A lot of them not peer-reviewed yet, but there's new information and nuance and questions, and so I'm going to try to go through this. I know some of us are science-backed people, and some are not. So at Eric's suggestion, I actually included a little basic virology. And we can go through this as quickly as we need to, but let me know. So let's get started.
Doc, before you actually get rolling, let me tell everybody who's joined recently, there is a built-in chat function. I will be collecting questions from the chat and relaying them to Doc. I'll let Doc lay out how he prefers to receive his questions and how he'll approach answering them.
Yeah, I think we can jump in whenever you feel like jumping in. Probably good to do that as the slides are up and we can talk about things. Just to let you know, I'm not an expert, truth be told. I'm an emergency urgent care physician, boarded in family practice, working at Duke Urgent Care. What I know is probably what a lot of people know right now. I'm not a virologist. I'm not boarded in infectious disease. I just put together the information I could find and analyze and try to give everyone an overview. We're going to talk about infections and viruses and COVID-19 and what's being investigated right now, what's on the horizon, what should you do, what should we be doing. And then at the end of the presentation, we actually go into some of the woo, the stuff that is out on the market right now and what's being sold as treatments and cures for COVID, and a little bit of a discussion about that. So we're going to start with a little bit of, what is this COVID-19? So it is a pathogen. There are different types of human pathogens. As you can see, there are bacteria, fairly common, viruses, fungi, protozoa. These are all organisms that can invade our body and cause disease. Some of them are healthy invaders that have a parasitic relationship with us, like the millions of healthy bacteria in our gastrointestinal biome. Some of them, like viruses, usually are not. When they get into an organism, they cause disease. So as a basic, again, virology, what's the difference between a virus and a bacteria? Here's the virus on the left and the bacteria on the right. Bacteria is about 100 times bigger. They're not actually the same size than the virus. Viruses are always contagious, meaning they spread from organism to organism. That can be from animal to animal or animal to human. There are some viruses in plants. They are always infectious because they have to reproduce, they have to enter the cell and shed their genome, their RNA or DNA that they contain, and then get the cell to reproduce more virus. And antibiotics, as I always say constantly, do not work on viruses. Bacteria, on the other hand, sometimes infectious. They can live in lots of different organisms and they can be a healthy part of the organism. They are sometimes contagious, spread from person to person, and antibiotics usually work with them. And these are some different types of viruses. My favorite is the bacteriophage, which comes right out of sci-fi. And these are viruses that land on bacteria and reproduce inside the bacteria. There's filamentous virus and envelope virus, which is what COVID is. So they take on some pretty neat geometric shapes and functional shapes. And this is COVID-19. This is an electron micrograph of it. You can see it is a spherical shape, and it has a lipid membrane, which is very important for us to know. And then it has these protein spikes. These sticky spikes are what seek out receptors and cell surfaces in the organism, in us and in the animals they came from, and help it attach. So anything we can do to stop that stickiness, stop that attachment, or break down that lipid barrier will help attack the virus. But this is the nasty coronavirus, COVID-19. So where did it come from? Why is it all of a sudden here? Coronaviruses have been around for a long time. We don't know how long. It is most likely a zoonotic infection with what's called species spillover. So we know that there are thousands of viruses that live in animals, particularly animals in the wild. As their habitat becomes more pressured, meaning that they are running out of wild habitat and they're now closer to domestic animals and humans, those viruses in those species, particularly birds and bats, have contact with other animals, as most viruses and living things do, according to Darwin. They mutate very frequently, and with millions and millions and millions of mutations, occasionally they hit the right mutation where they can make a jump to another host. And then they will go to a host that we're more exposed to, like domesticated animals. This is a civet down here. And occasionally then they make the jump to humans successfully. They probably make these jumps a lot, but not successful enough to reproduce in numbers needed to establish a host. And then humans can sometimes transmit them to each other. As an example, avian flu is very, very common. People that own poultry farms know that they are constantly dealing with avian flus, but they're usually successfully treated and limited to the livestock. This virus, you can see previous coronaviruses down here, MERS and SARS, the acute respiratory syndrome and Middle Eastern respiratory syndrome. They most likely jumped from bats, which have a lot of coronavirus in them. The MERS jumped to camels and then jumped to humans, which is why it started in the Middle East mainly. SARS, which is one of the last ones, now called COVID, not COVID-1, but it's the original, so it's just COVID, jumped to, we think, civets, and then to humans. And that's probably why the infection grew mostly in Southeast Asia. And then there are several other viruses you see here, like the H5N1 bird flu. So that's what happens. These wild animals have these viruses. These viruses, because of proximity with domesticated animals, will occasionally make a jump. And their proximity with humans, occasionally they'll make the jump to humans and then find a way to transmit from human to human once they find a receptor in our bodies that they can fit with the mutation. So coronaviruses have been around for a while. This virus, just to get the nomenclature down, this particular coronavirus is known as SARS-CoV-2. And nobody's really happy with the names. Who is not happy with it? It was called the novel coronavirus, and they still use that term a lot. Just because it was a new coronavirus and no one could think of another name for it. But the disease that it causes is now called COVID-19 because it started in 2019. Also known as coronavirus disease 2019. The names may change, but I think we're all getting used to COVID-19, which is now used interchangeably for both the virus and the disease itself. There are 7 types, and this is something that I hear online a lot, and I have to address. Someone will say, oh, coronavirus is just a cold. They're not dangerous. What's all this to do about it? Well, it's partly right. The first 4 coronaviruses that you see here are in common colds. They do invade the human respiratory tract, but they're usually not dangerous, and our immune system can handle it. Then came MERS-CoV, which is a beta coronavirus that caused the Middle Eastern Respiratory Syndrome, or MERS. The next was SARS-CoV, again, not SARS-CoV-1, they don't put the 1 on it, which is the beta coronavirus that caused severe acute respiratory syndrome, or SARS. You probably saw pictures a few years ago of all the people in Asia, Southeast Asia, that were wearing masks, and we were watching for it in this country too, but it got under control. And now SARS-CoV-2. So this is what we think. Initially, they thought it came from cobras in the markets in Wuhan. Now we think probably from bats, which are a common host to coronaviruses, and maybe made an intermediate jump to, this is a pangolin down here. Kind of looks like an armadillo, very common in Southeast Asia. And the reason why all of these diseases are coming out of Southeast Asia, there's a confusion between the term wet market and wildlife market. Having been to Singapore a lot and to Korea a few times, wet markets are basically a big supermarket. It's an open stall with many, many different vendors in it, and they sell lots of different produce and products. It's actually a way of an alternate to the standard supermarket in these areas, and very successful, and somewhat regulated by health codes. The problem is the wildlife market, and you can see that down here. And this is where, for different reasons, either for food or for traditional Chinese medicine, TCM, these wild animals are kept in the market, and frequently they're alive and kept close to the food and people. And that's where we think a lot of these new viruses are making the jump to humans. So there is a difference between the two. If you condemn Chinese wet markets or Oriental wet markets, that's a big source of food for everybody. It's the wildlife markets. I find it ironic that people are now pushing traditional Chinese medicine as a possible cure for COVID-19, when that is probably the source of it. This is data from today from Worldometer. I have some links at the end in the slides where you can click on it. This is worldwide. We're now up to 212, almost 213,000 cases, and 88,000 deaths, about 84,000 now recovered. The number of cases that you'll see is probably a gross underestimate. So what's called the denominator is probably a lot lower. As we're testing in countries like South Korea and Hong Kong and China, where they're testing a lot of people, and most of the world now is testing pretty much everybody, we're finding there are a lot more positives, and particularly asymptomatic or people with minimal symptoms, and even maybe some coexisting influenza and COVID infections. So this number is probably much bigger than this. There are probably a lot of hidden cases right now. We already have about 60 cases, I think, in North Carolina. Nobody's seriously ill, nobody in the hospital that we know of. But since we started testing a few days ago, the test became more available to us. We're beginning to find a lot of positives.
Okay, I'm going to jump in and say, because I don't know how to send this to you.
Yeah.
I just checked it. It's 218,000. It's gone up 5,000 since you got that number.
Wow.
Oh, so yeah, I loaded this a few hours ago. and the number has jumped up. So active cases, we have about 120,000 active cases as of this morning. Currently infected in mild condition, about 113,000. That's about 94%. This is worldwide. And about 6,600 in serious or critical condition. These are active cases. Closed cases, meaning we've had some outcome, about 84,000 or 91% recovered or discharged, which is good. 9% death. Now that sounds like a high number, 9%. But again, these are cases that had an outcome. There's still a lot of people that are under investigation where there's no outcome of the case. So that's the closed cases is going to reflect a higher percentage of fatalities. In the United States, as of this morning at
one question, sorry to interrupt, Joel. Just, are these numbers the same that I've been hearing around, that mild means not really necessarily mild, but that it means that you didn't need a respirator?
It means you didn't have to be, mild means you didn't have to be hospitalized.
Ah, okay, that's a different thing then.
Right.
Okay.
So these are people who come in to see me that have a cough, maybe a little fever, have maybe a little sore throat, but they don't require hospitalization and they can quarantine at home. Serious or critical would be people that needed to be hospitalized, probably ICU or ventilator.
Doc, so sorry, this is Eric. Another quick comment. So that death rate is for cases, and granted, there may be lots and lots of people who were infected but never even had any symptoms.
Correct.
Do we know from any of the countries that have tested a lot, what is the proportion of people who were infected who even get symptoms?
I'll talk about that a little bit
Okay,
in some
thank you.
slides, but the problem is it's very hard to collect data like that in an ongoing epidemic.
Right.
The number is sometimes multiples off.
Right.
So in the United States, as of this morning, almost 7,800 cases, 117 deaths, which isn't that high, and 106 who've recovered. So we don't have a lot of recovery numbers because it takes for people to recover, and we're still not sure what's a marker of someone that recovered. People are testing negative, the PCR test or their viral load tests are negative, but then a lot of people are getting sick again. We don't know whether that's a reinfection or whether that's like flu following several phases of the same infection. But we have 106 that have recovered, and active cases in the United States, about 7,500 active cases currently.
Joel?
Yes?
It's now 9,200.
Why don't we, I suggest we not interrupt Joel, because we know those numbers are going to go up, but just let him get through it.
Yeah, well, it's just in a number of hours, it went up to that.
Oh, that's fascinating. So it's gone up several thousand from this morning till now. So there are about 7,500 or almost all in mild condition in this country right now, and 12 in serious or critical condition. Of the closed cases where we have an outcome, and again, closed cases means you either recovered or you died, so there's a skewing towards death. About 106 are officially recovered, discharged in good health, and 117 deaths. I added Canada. I don't know if anyone from Canada joined. I sent an invitation out to some friends in British Columbia. But for these in Canada, about 600 cases with 8 deaths. This is a dated graph from March 12th, and this shows the increase rate in different countries. Two things that are interesting here. One, a lot of places you see a exponential increase in cases, and the exceptions, which I find interesting. South Korea had an exponential growth and then starts blunting its curve. Why is that? We think because South Korea started taking action right away. They made the tests available. They started screening people everywhere for fever, putting people in fever clinics, separating people from their families, not just saying, go home and quarantine, but we're going to take that family member out of the family group so they don't infect their family and put them in fever clinics. And they're finding that the curve is blunting by treating this aggressively. It's been effective, but we're not doing that here. Japan, we're not sure. Japan has a growing number of cases that it's just on a slower curve. Don't know if that's because they're not testing a lot or the spread has slowed. Singapore is very interesting to me because my family lives in Singapore. They only have a few hundred cases last time I checked. Now, this is a country state of about 5.5 million people living in a very small shoulder-to-shoulder area with open wet markets and a very large Chinese population. But they don't have that many cases. I've talked to my son, and we think it's a combination of the community spirit and a community morality in Singapore. So nobody goes out without a mask on, which doesn't protect them, but protects other people, particularly if you have a cough. If you walk out the door into the malls or marketplace, and there's really not many places to go in Singapore that aren't crowded, people will come up to you and wag their fingers at you and make faces at you. That and government got on this right away and started quarantining people, tracking the cases. They found an outbreak in one of the churches, Grace Church, and they found all the contacts and all the family members and isolated them. And Hong Kong had the same community response and massive testing, and you could see they're all increasing, but at a much slower rate. So we don't know. There are several theories of what might be going on, and I'll talk a little bit more about that. And here's one of the theories, and I just read this today and got on this site. There may be multiple strains. So we've all heard about there might be 2 strains. Well, what they found in doing genotypes all around the world and sharing the genotypes and tracing it from Wuhan is there may be about 280 strains of COVID-19 now. That it seems to be mutating somewhat as it spreads. And there are main, what are called clades of this, with an S type, a G type, and a V type. S mostly China, South Korea, and the USA, which may be why we have milder cases here. The G going through Northern Europe and Russia, and the V through Singapore, France, Italy, Latin America. You can see these groupings down here, which nobody can read on this slide. But this comes from GISAID initiative. This is the global initiative on sharing all influenza data. And these are people who are running the genomes of local outbreaks all over the world and posting them so that this is shareable data. So we can look at this data and we can analyze it. This is the hyperlink that if you download the slides, you can click on it to get to that site. This is from that site. And here you see tracing of the infections, and as they mutate, the colors change coming out of Wuhan. This is the United States down here in orange. So we can see that it's splitting and the genome is changing as it spreads throughout the world into more and more and more subtypes. Are these, I don't think these are completely separate strains, but these are subtypes of the genome. What does that mean? That may explain why some places like South Korea, maybe Singapore, and maybe the United States have milder cases overall and fewer deaths, that the genome that we have right now is a milder strain. It doesn't mean it will stay that way as we don't limit people from moving around. But that's one explanation. If you go to this site, which I put in the link, GISAID, this is an interesting map. I can't play it here right now because this is just a slide. But if you click on Reset and Play, it'll start in Wuhan. And then over time, it'll show how this spread and then how the genome changed in different places as it spread. It's kind of interesting to watch it unfold.
Hey, Doc.
Yeah.
Feel free to tell me that this is coming up. I expect it is. I've been waiting for two shoes to drop, those being Africa and Russia. Any
Right.
thoughts on that? Are those coming up?
Well, you can see some cases in Africa, but not many. And one of the questions we're asking is why not?
Right.
Is it that there's not a lot of travel into and out of Africa from surrounding infected areas? One theory was looking at South America and Africa, that it might be the warmer climate, but that doesn't seem to be the case. There are cases in Australia where they're in their summer, or just coming out of summer, and cases around Malaysia and Indonesia. We don't know. Russia, I'm interested in to see what happened in Russia and not. Maybe they're not reporting it. That's one theory. I don't know. It doesn't seem to be the temperature. It doesn't seem to be the cold. It seems to be the population. I will say there are no cases in Antarctica, but I think it's because there's nobody in Antarctica.
Nobody going there.
No one going there and no one coming from there.
And actually, Doc, this is Eric again, real quick before we leave
Yeah.
that previous slide. Actually, I think, and if you go to actually the one before this, it cannot, I'm sorry, the one before this, I apologize. If type V is in Singapore and Italy, it cannot be purely a strain type that explains the spread and lethality. It's got to be, I mean, I think there's like no better argument in favor of social distancing than I think that finding right there.
And I think that's true of Singapore. The combination of the government reacted sanely, tested people, isolated people. I saw a case chart out of Singapore where they know each case and where it went and who they were exposed to and how they isolated it, and social pressures.
Right.
In Singapore, there's very little crime. Part of it is because they have a pretty austere police. You've probably heard people getting caned for spitting gum out. It's not quite as harsh as that. It's you know, if you steal a bicycle theft is one of the biggest crimes in Singapore, really. If you steal a bicycle and they catch you, your picture goes up all over your community, and you and your family are shamed for what you did. And there's a lot of this cultural shaming. If you go on the transit, the rapid transit, it is patrolled in a way by a bunch of women, mostly Muslim women because they got the jobs. And they patrol the trains, and basically they're looking out for people not acting socially responsible. So if you have children, teenagers acting out on the train and making a lot of noise, which is rare, they will grab them and shake their finger at them and say, I'm calling your parents. And that keeps everybody in line.
Wow.
So it's that pressure. They're up and downside to it, but the upside might be in this pandemic, everybody cooperates out of this sense of duty to community.
Right.
Does that answer your question?
Oh God, yes, absolutely. No, I just wanted to make a quick comment. Thank you, Doc. I totally agree.
So this is just, you hear me say it's just the flu. I said that at first because I know that death rates in certain flu epidemics have been very high, but it's not just the flu. It's a little bit worse than that. Here is flu. This is the case fatality rate you're looking at, which is the number of fatal cases per diagnosis, and distribution by age. And this changes because H1N1, it was actually more younger people in this group that died than older folks. But here is COVID-19. And you see where the risk seems to go up as we get older to over 80 is 15%, which is pretty high roll of the dice.
Wow.
In other areas like South Korea, they're finding different numbers with maybe more cases now down here than up here. Again, it might be a different strain, and that may be why that developed. They're finding more women than men getting infected, where we're finding more men than women.
These are U.S.
We don't know
These are
why,
U.S.
but
data.
it might be different strains.
I'm sorry. These are U.S. data or world?
This is from CDC.
So U.S. Okay.
Right. Also, the Chinese Center for Disease Control. But basically, if we look at all flus as one, I mean, you can't really show flu because there are different swine flu, bird flu, different epidemics that have different fatality rates. But in general, this seems to be worse. So how serious is this? I would say pretty serious. When you hear data, you have to kind of sort it out by what's called the case fatality rate and overall mortality rate in statistics. Case fatality rate is basically the number of people that die from a certain disease compared to the total number of people diagnosed with the disease over a certain period of time. So when you say something like case fatality rate is 6%, that means not 6% of the population, but 6% of the people that are infected died. The mortality rate, frequently confused with the CFR, is a measurement of the number of deaths in general due to a specific cause in a population, scaled to the size of that population per unit time. So this is how many people died of this thing in this size of a population during this time. So those are two different numbers that frequently get confused. I don't know if that's clear or not clear.
Again, I'm sorry to interrupt, but the mortality rate is not just deaths per total U.S. population, right?
No.
It's mortality rate per people known to have been infected, maybe not even that showed symptoms.
Well, the mortality rate would be the number of people, and this won't be known until we're done.
Right.
The number of people, it would be the number of people, if you're talking about the U.S. mortality rate, the number of people that will die of COVID-19 in the population of the United States, what is it, 300 million now?
Oh, okay.
Over the time of the infection.
So maybe it's fair to say that a case fatality rate could be a special case of a mortality rate if the population of the mortality rate is the infected population, the diagnosed population.
Right. So the case fatality rate will say, what's your chance of dying from this disease if you get diagnosed with it?
Right. And that's a higher than what's your chance of dying from this disease if you get infected, because a lot of people infected won't become a case.
Right. Right. And that number we're going to see is going to change because as we do more testing, we're going to find large numbers of people that are asymptomatic.
Right.
That, they had the infection. I don't know if they had the disease.
Right.
And they survived. They just, a physician in, I think it's Vo, Italy, just published a letter. They tested all the residents of his small town in Italy near Venice, over 3,000 people, and they found a high number of people that were positive. Something like 50%, I think, is what they came up with of the 3,000 some odd people in the town that were tested. And most were asymptomatic or very, very minimal symptoms. And they were able to isolate all the positives, and the number of new infections has dropped way down in that area. But we may find the denominator is way larger than we think it is, so the overall fatality rate may be a lot lower than it seems to be right now, as we start adding a lot of asymptomatic people that are going to survive into this. And so again, how dangerous is the virus? We look at a few parameters. One is the transmission rate. You might have heard of R subset 0. And that's basically how many people will get infected by each infected case? We think the R subset 0 right now for this is 1.5 to 3.5. That may go up as we start discovering all of these asymptomatic people. And it differs from area to area. You want that number to be below 1. If the R null is below 1, it means your infection is dying out and will gradually disappear. For comparison, the R0 for the common flu is about 1.3. That's all flus. SARS was about 2. Measles, which hangs out in droplets in the air for hours, was 12 to 18, which is why it's really bad when people don't get immunized and we get an outbreak. Aerosolized versus droplet, how does it spread? We still don't know for sure. It seems to be mostly heavier droplets higher than 5 microns that land on surfaces, and then we bring them up to our respiratory tract with our hands. They've done a few studies that just came out on how long does it last on different surfaces. And it can be anywhere from about 2 hours to 2 days. Now, having said that, the likelihood of picking it up from touching these surfaces and touching your face is lower than people would think, but it is one way to spread that. We're still using face masks in the clinic. We're still using N95 masks for high-risk procedures and patients that may be infected, and surgical masks for the rest. And we're not leaving rooms empty for hours and hours and hours, since we're not doing high-risk procedures like intubation. And then we look at the case fatality rate that we just talked about and determine whether asymptomatic transmission is possible. Since I made the slide, we now know that there probably is asymptomatic transmission. And that's one of the problems. So again, looking at fatality rate, that can vary by area. It seems to be 2 to about 3.6% fatality rate, that's case fatality rate, in high-risk areas, like Wuhan. If you look at the rest of China, it's about 0.3 to 0.6% overall. So the fatality ratio of the disease seems to change from area to area. Is that because it was treated differently? Is it the viral load within the area and the amount of virus people get exposed to? Is it the change in the genome? We don't know. It does seem to be skewed in most areas to over 65 and people with chronic illnesses like diabetes and immune suppression. And the data actually isn't in talking to infectious disease at Duke on people that are immune suppressed, like under cancer treatment. We just don't have numbers for that group, but we're assuming that group is also at high risk. And we don't know the denominator without testing everybody. So again, as you test more people, you get more positives with mild disease, and the case fatality rate actually comes down. The number again from Korea suggests about 0.3 to 0.6%. Comparison to other viruses, case fatality rate with seasonal flu in the United States is less than 0.1%, 1 death for every 1,000 cases. The exception there are previous flus like the Spanish flu of 1918 and the 2009 H1N1 epidemic, where there were 1.6 million cases worldwide and about 250,000 to 500,000 deaths worldwide in 2009. So flu varies from season to season. The case fatality rate with SARS was 10%, and for MERS 34%, but there just weren't that many cases overall. And there. So this is a quote from someone. At present, it's tempting to estimate the case fatality rate by just dividing the number of known deaths by the number of confirmed cases. However, that doesn't represent the true case fatality rate and might be off by orders of magnitude. So you really can't calculate these things until we get all the numbers in at the end. If you wanted to be more precise, and those of you who love math, You have to use the case fatality rate as the death at day X divided by the cases at day X minus the time, the average time from the period from case confirmation to death. Now, I know it's a little hard to wrap your mind. I have trouble wrapping my mind around that, but what it's saying is you can't get a good case fatality rate as people are still being treated, particularly in this illness where it may be several weeks before we know the outcome. Symptoms, most people have mild symptoms or asymptomatic. Symptoms can include fever, cough, shortness of breath. At first, we didn't include sore throat and runny nose, but now we're seeing that in some patients, but that's not a major symptom. It can also invade the GI tract and you can get diarrhea. Again, 80% in general have mild cases. The duration, mild cases last about 2 weeks, severe or critical cases 3 to 6 weeks. Time from the onset of the development of severe disease, which is usually about 1 week into the illness. So people are going around mildly ill, and about a week later, they become severely ill. Among the patients who've died, the time from symptom onset to outcome ranges from about 2 to 8 weeks. Again, the other thing we're seeing now for duration is some people who had mild disease got better, fever went away, they go back out of isolation and they get sick again. And frequently what we're seeing in other areas of the world, when they get sick again, it's a much more serious case. We don't know whether these people have been reinfected. Did the first infection lower their immune system so the virus re-entered and have a more virulent response? Or is there sort of a two-pronged response where it tweaks your immune system to go into hyperdrive and then you develop more severe symptoms? So that information still, we don't know. So here's some of the gruesome stuff, but to understand what it does, what does the virus do? This virus tends to go into our respiratory tract and get down into the lungs. The receptors tend to want to find the cells in our lungs, in the air sacs or alveoli of the lungs. It will attach to the two main cells, which are the goblet or mucus cells, and the cilia cells. These are cells that have little hairs that waft back and forth that help bring mucus up and out, which are what make you hack up big hunks of mucus and get it out of your body and out of your lungs. When it attacks these cells, the mucus then builds up in the lungs, and the lungs start to fill up both with mucus and other immune cells and fluid, and you start not being able to exchange air. The alveoli become stiff. They may become porous. What we see on X-ray and CAT scan is sort of a ground glass appearance. A multi-lobar, multi-lung lobe pneumonia, and then bad things can happen from there. So what happens is the virus enters the respiratory tract, it attacks the goblet and ciliary cells, as we just said, mucus builds up, lungs fill with fluid, you develop a pneumonia. Some people get better from that. Then your immune system kicks in to help you out, which is kind of a good thing. And you make macrophages, which then also activate neutrophils and T cells, which try to attack the infection and any secondary bacteria that might get in. If it stops there, we're good, and we can you can usually weather the storm of the pneumonia. You might have to be on a respirator for a while. However, sometimes the immune system goes into overdrive, and you develop what's called a cytokinetic or cytokine storm. The body releases these inflammatory cells, chemicals, cytokine, which then cause massive inflammation in the air sacs of the lungs, which are now filling up with fluid and necrotic neutrophils. And you get not only an inflammatory response in the lung, which is acute respiratory distress syndrome or ARDS, but it affects the whole body. and you can go into multi-organ failure. Your kidneys shut down and everything else starts to shut down. Not good. Unfortunately, it's a small number, small percentage, but this is what can go wrong. Our bodies actually, our immune system may be part of what kills us. And this is just another slide showing the same thing, that it goes down into the lungs. And so for now, everything you've been told is true. Wash your hands, since this seems to be transmitted by contact more than aerosolized droplet. Wash your hands, and we'll see why that's important. And number two, did I say wash your hands? So I can't overemphasize how important it is to wash. Soap is, any kind of soap is good. Saponification is our friend, but wash. If you don't have soap on hand, sanitizers that are at least 60% alcohol are also good. Don't use vodka, as some people have suggested. Drink the vodka, you'll need it, but don't use it as a hand sanitizer. If you're going to make your own, and I've seen that online, make sure you know how to do it. If you don't make it right, the alcohol content will be too low and it won't work, or your hands will get irritated. Sorry, I'm getting a message from some of the people in British Columbia.
I hear barking.
Yeah.
Sorry, that was me.
I wanted to know if they were too late, so I told them to sign in. Sorry about that. Keep your hands below your collarbone and away from your face. I find this much better as a positive direction than don't touch your face. Just keep thinking of your collarbone is the border. Keep your hands below your collarbone. If you have to, and people say, well, what if I have to adjust my glasses or scratch my nose? Wash your hands first. That's all you have to do. Wash your hands, then touch your face. Assume that all surfaces are contaminated. We really don't know how long the virus will persist on each surface. Could be hours, could be days. Social isolation for now. So avoid large groups, and I don't know how you defined it. At first they said 500, then they said 100, now 50. I stay out of any group larger than a few people. Avoid air travel if it's not necessary to go, although you could fly. Just be really, really careful about what you touch and how much you wash on the plane, but particularly avoid international travel. I was supposed to go to Cuba in next month, but that may be canceled because they have some cases now and a lot of people are canceling the tour, and nobody wants to get stuck in Cuba when they're sick. And definitely avoid cruises. Worst place to be. And keep yourself generally healthy. The healthier you are, the healthier your immune system, the better chance you have of fighting this off.
Doc, I'm sorry, real quick,
Yeah.
before we leave that slide,
Yeah.
given that this is a respiratory disease, that it attacks, I thought specifically cells in our lungs, why is touching your eye or touching your nose so, why does that matter?
So the virus has to get to your lungs, and the way it gets to your lungs is through the tubes that go there, and that's your nose and your mouth. So if you touch your face, you're introducing the virus around the entryway to your lungs, and then the virus can travel down.
Right. So eyes are not necessarily a...
Well, as far as the eyes, there's a lot of discussion now. There's some articles now about conjunctivitis with COVID-19, and can the virus enter through the eyes? We don't know. There's still a lot of active discussion, particularly amongst ophthalmologists about that. For now, we're still wearing either a face shield or protective glasses.
I think even if it just gets into your eustachian tubes, you could still respirate it from there, right?
Well, that's the thing. If it gets into your nasal oral passages, and that's the way it gets in, and then it goes down from there as you inhale. So keep healthy. One thing that came up was ibuprofen or acetaminophen or paracetamol or Tylenol. Which should we use? There's a whole bunch of stuff now online, some good, some bad information, a lot of posts of there's a doctor in my family and they said, where did this come from? So this came out of the French health minister, Olivier Véran, who's a neurologist, found that there were a number of cases, they quote like 4 cases of young people who ended up with severe disease who were taking ibuprofen or cortisol, a steroid, before they got sick. So there is a theory that the anti-inflammatories, the non-steroidal and steroidal anti-inflammatories, may suppress in the inflammatory response that initially is necessary to fight the disease. There was also a virologist at University of Reading who said the same thing. Now, is it true? Well, the discussion group I'm on, there's mixed opinion about it. The British National Health Service and the British Medical Journal initially came out saying it didn't make a difference, and now they're saying don't take anti-inflammatories if you don't need them. And I think WHO just came out to support this too. But the scientific basis and the data is pretty weak. It's just sort of, we don't know, but if you can take acetaminophen, that's fine. And that means if you're already on an anti-inflammatory or particularly on cortisone for something serious, consult with your doctor before you stop it. But I just bought a little more acetaminophen just in case. There's the National Health Service first said no strong evidence that it can make coronavirus worse. Until we have more information, take paracetamol, which is their acetaminophen, unless the doctor says otherwise. So at first they said, no, don't believe the stuff. And now they're saying, well, it couldn't hurt. The other interesting side of that is they're now using a non-steroidal anti-inflammatory, tocilizumab, from Roche pharmacies into China to treat the cytokine storm. So, and some doctors in Italy, in Naples, have been using it on severely ill patients. So, because the molecules interfere with interleukin-6 and an inflammatory substance. So you kind of have this dichotomy where don't take anti-inflammatories early on because you want the inflammatory immune response. But once your immune system kicks into hyperdrive, you want to stop the inflammatory response. So anti-inflammatories may be the way to go. And that's kind of the way I look at it now, that when you're in cytokine storm and your life is threatened, the anti-inflammatories may be necessary to shut down your immune response before it overtakes you. Whereas early on, not taking anti-inflammatories may help you. I don't know if that's clear to anyone, but a lot of us physicians online are scratching our heads saying, okay, it maybe makes sense. Other things that you may have heard, do blood types affect the infection response? That's the latest paper out. Certain blood types may make you more susceptible to severe response. Small paper, not peer reviewed, we don't know. Do we develop antibodies after the infection? And we would hope that we do to protect us. But there are some reports of more severe reactions in survivors with a second infection. So maybe we don't. Small study showing a high asymptomatic infection rate and success with isolating asymptomatic infection we talked about. When is the infection over? We don't know. We're telling people isolate for 2 weeks, trying to redo the PCR testing to see if there's virus in the system. But does that mean for sure that they're not contagious? We don't know for sure. Okay,
Maybe lay out PCR for people who don't know what that is.
PCR is testing for the actual virus rather than antibodies. So it gives you a viral load. This shows us why hand washing is good. So here's the coronavirus. and the lipid membrane and the little spiky, sticky proteins, and the RNA, the genetic material, is inside. And this is our friend soap, which some of you from organic chemistry may remember, has a nice hydrophilic head, which loves water, and a hydrophobic tail, which hates water. So that when you wash with the soap, that binds the hydrophobic end will bind with the lipids and break up the lipid membrane and release the spikes, and also carry dirt with it, which may also have more viral particles around with it. So soap, any kind of soap, it doesn't have to be antibacterial soap, does a good job. This is why we want to wash. Again, washing your hands doesn't mean put it under the sink for show. It means washing. Doesn't have to be hot or cold water, running water. Any kind of soap, liquid or bar soap, lather together. Friction is important. So you want to rub your hands and rub the palms and rub your nails and get into every little crevice, including your wrist, for at least 20 seconds. So you've heard sing happy birthday to me twice. And that's a good one. I've come up with all these different melodies in my head, and then I can sing to myself and change off so it doesn't get boring. But you want to do that. You want to, it's friction and soap. And then rinse thoroughly with water. And I can't see that slide under there, but it's basically dry thoroughly. So you want to dry the area thoroughly. If you leave the hand moist or wet, or you wipe it on your pants, you haven't accomplished anything. Then the other is, how do you get out of the bathroom without getting recontaminated? I use the paper towel to shut the water off, which I've always done, because I know what's on faucets in bathrooms. I don't use the hand dryer, and there's a lot of controversy, I know, on the SGU about hand dryer versus towels. For this, for disease, not for the ecosystem, hand dryers just have too many microorganisms in them. I wouldn't use them. And then I use, if I'm not in a bathroom like at the airport where there's no door, or occasionally I see one that has a little bar device where you can put your wrist in there to open it, or a little foot grabber. You can open the door with your foot. Use the same paper towel to open the door, and then throw it away. And I've always done this in public bathrooms, is flush with your foot. If it doesn't have an automatic flush. Keeping things in perspective.
Hey, Doc, I got one for you from the chat. A question about breaking up the mucus that that was mentioned in some of the earlier slides. Do you recommend like Mucinex or guaifenesin? Is there an opinion on that?
I don't have any opinion. I don't use it much in regular infections. I think in this type of infection, there's such an overwhelming load of mucus that guaifenesin, which is what Mucinex is, probably isn't going to help very much. I mean, it breaks down the surface tension of the mucus a little bit and loosens it up, but if that happens, if you have a lung infection, your lungs are just overwhelmed. And so I don't think those things will help very much. In regular infections, I don't like it because it loosens it up and then people are coughing more. And it's the cough they want to get rid of. But here you're dealing with your lungs are drowning. There's so much mucus in there. So keeping things in perspective, kind of the rosy side of this is, we know what this is already. Within weeks, China, I mean, people give China a bad rap because it's the origin, but the Chinese were on this instantly, even though they were publicly denying it. We know what the virus is. Within weeks, we had the genome, we had the structure, we had all this information about the virus. We know how to detect it. We have good tests. What we're working on now in a lot of labs is rapid testing, good, effective rapid testing. For me as a clinician, what I need to know is, do you have the virus? And I need to know right away. Right now, locally, the turnaround time is about 3 to 5 days. So that's a long time to wait, not knowing if a patient has this, assuming that they are not super sick. The situation is improving in China, so their case numbers are dropping, and 80% are mild. People seem to be getting better, those that don't die. Symptoms appear to be mild in children, including infants, which is another good thing about this. So children are getting infected, but they don't seem to be developing severe symptoms overall. The virus can be wiped clean, as I said, ethanol over 60%, 60 to 70%, hydrogen peroxide 0.5%, sodium hypochlorite, a very dilute bleach 0.1%, will clean it in a minute. So we can clean it, we can get rid of it. Science is on this globally, so I'm on a lot of these websites now. Yay, science. Again, when I started this, the day after I talked to Jeff, I went online and there were about 160 articles on PubMed related to COVID-19. Latest check, there are over 1,200 articles on PubMed. Most of them are peer-reviewed, but a lot of them aren't. And this is the link to that website. So data is being shared, including the genomes that we're finding. All this data is being shared, treatments are being shared in articles. Everyone around the world is on this and sharing data as long as we pay attention to it. There are already vaccine prototypes. About 15 or 20 companies, I think, right now are working on vaccines. A lot of different modules, a lot of different methods of working on the vaccine, including artificial intelligence and computer design. We did have a vaccine, I think, out of Baylor for SARS and MERS. So some people are building on that and seeing if we can use that as a basis for vaccine. The problem with vaccine development, why we're not going to have it tomorrow, is we have to put it through clinical trials. We have to know that these are effective and they are safe. When they were developing the RSV, respiratory syncytial virus, which is a severe respiratory illness in children, young children, they came up with a vaccine, but during phase 1 trials, where they are right now in some of these vaccines, meaning they're testing it on volunteers, they found that some children were reacting to the vaccine by releasing eosinophils into the lungs, making them worse. They were getting an eosinophilic reaction that nobody could have predicted. And they had to stop the test and redesign the vaccine. So we don't want to all of a sudden release this miracle vaccine everywhere and then find that not only when you release it in a large population, it not only doesn't stop the virus, but creates other problems. So I'm thinking it's gonna be about a year at best until we get a vaccine. I've heard 6 months. I'm not sure how they're gonna do that. That would be great, but don't look for it tomorrow. A lot of antivirals are under trial. There are over 80 clinical trials right now analyzing different treatments. There's an antiviral remdesivir, a broad spectrum antiviral that's being tested. It was used previously against Ebola and SARS-MERS. Chloroquine we'll talk a bit more about, an anti-malarial drug, which has some antiviral activity. And in Korea and China, they developed treatment protocols using chloroquine right now. It probably works through several different mechanisms, including increasing the acidity or pH of the endosomes where the virus replicates, and helps break it down. So it blocks the virus in the body in vitro. So we're testing that, and this would be something that they are now using people that already developed pneumonia and severe reactions. Telmavir used against influenza is being looked at, as well as I think China and South Korea have a protocol using multiple antivirals in a pill. There's one that's being used for HIV right now that have 2 strong antivirals, and that's one of their decision branch protocols for severe pneumonia and people with cytokine storm. They're looking at interferon 1b, which is a protein with antiviral function. They're looking at developing an antisera from people that have gotten better, or monoclonal antibodies to neutralize the virus. That's a small arm of investigation. New therapies, inhibitory substances such as baricitinibine, and some that have been selected by artificial intelligence. So you may have heard about artificial intelligence being used by pharmaceutical industry to suggest possible drugs to treat different diseases once it knows the target. Several of those have already been designed using other drugs and changing part of the structure of the drug. We've now released it on this to see what it can come up with. Chloroquine, and again, to remind you, this was a 15-minute talk when I started a month ago. Every day I add a couple of slides. Chloroquine is a really interesting area. So it's chloroquine and zinc. There's some old papers looking at chloroquine and zinc, or chloroquine specifically, in treatment of cancers. This is an older paper from 2010 looking at inhibition of zinc in coronavirus. These are early coronaviruses, when used with what's called an ionophore to block the virus in cell cultures. And I'll show you what that is, because I find it fascinating. I've looked into zinc in treatment of viral infections for a while. It's been studied against influenza, and it's been studied against colds. For a long time, people are using it intranasally. We don't know. The studies have been, the metadata on that has been sketchy. I will, full truth, I recently had a cold and I was desperate. So I usually take zinc orally, but I crushed a tablet and made a colloidal suspension and inserted it in my nostrils with a Q-tip. And anecdotally, my cold only lasted about 2 days and I was feeling better. Did it work? I don't know. It's anecdote and it's one trial, but here's a very busy slide. I'll try to talk everyone through this. So this shows what's happening in the cell. If you can picture it and remember your microbiology, this is the cell wall. Out here, this is the nucleus wall. So normally our genome, our DNA, is translated by transcription RNA and leaves the nucleus as messenger RNA, where what's called a 5' and a AAA end are inserted. That allows ribosomes to link to it and start cranking out the amino acid chains that become the proteins. And that's what's called translation. So it's making protein that the cell needs to replicate or perform its function. That's normally. Here comes coronavirus, which has its own genome, in this case RNA, enters the cell, releases its RNA, again gets a 5' and a AAA, don't ask me what that is, on each end. I don't remember that from microbiology, but then uses something called RNA-dependent RNA polymerase to start manufacturing its proteins through transcription. And it starts making more viruses. This is how viruses replicate inside our cells. So it tricks our cells into making more virus and then releases them. This here is called an ACE2 receptor. And that's a little bit controversial now too, where we're looking at this might be the active sites for binding, called the ACE2 receptor. What's interesting about that is we use pharmaceuticals that block these receptors to treat hypertension, what are called the ACE inhibitors, like lisinopril, and the ARBs are classes of antihypertensives. And now some people are saying, well, does that mean people who are taking these medications are more susceptible to the virus? We don't know, but I don't think we know enough to tell people to stop taking their heart medicines. So the next thing we see is what they've discovered is zinc in the cell will block that protease that is needed to to transcribe the viral genome. It will stop it. The problem is getting zinc, which is a ion, 2+ charge, into the cell. And that's why we don't know if it works on colds and things. But how do you get the zinc? Because ions with charges don't go through the cell wall. Well, you can open a gate in the cell wall with something called an ionophore. And so basically it's opening a gate, letting the zinc in. And they've actually studied this using fluorescent zinc molecules. And they see like how much gets into the cell and into the lysosomes in people just taking big doses of zinc, which isn't very much. How much will go in if you have the ionophore. And that greatly, like 300-fold increases this. So if you can get the zinc into the cell, it blocks the transcription of the RNA from the virus. So how do we do that? Well, here's the paper that says chloroquine is a zinc ionophore. So we're using chloroquine was initially studied, which is an anti-malarial. It's how we treat malaria. It was used to see if it could kill cancer cells, looking at its effect on cancer cells. And they found that it actually, with zinc, helped to destroy the ovarian cancer cell line. So we think what happens is chloroquine opens up a gate to allow zinc into the cell, which then kills off the virus particles. And adding things like copper and other things to it doesn't seem to help it out at all, but it's the zinc. So they have a protocol now in Korea and in China where they're using, and I think in Italy they're starting to do this too. They have a protocol for how much zinc and how much chloroquine can you give someone, because chloroquine does have serious side effects. So what's the good dose and what's the good dose of zinc? And they're getting some good data back on its efficacy.
And
so that is something on
sorry,
the, yeah.
just anecdotally, I've had the dubious pleasure of having to take chloroquine, tablets called Aralen. And what I can say about it is the fullest tasting thing I've ever come across in my life. It's, imagine the bitterest thing you can ever consume and multiply that by, I don't know, 20 something. It was unbearable. I used to chew crystallized honey to try to get the flavor off my mouth.
Bad stuff.
It's pretty bad.
But I was going to a malaria-infested place, so.
Yeah, other than the foul taste, it can have some bad things to the body too, bad side effects. But the dose that they're recommending and the protocols seem to be safer. And we're talking about people that are going to probably die if they don't get some effective treatment. So they don't care how it tastes.
I've got a question.
How are they giving of each in the protocol? I'm just curious.
What is that?
About how much of each is being administered in the protocol?
I had that in an article, but I don't have it at my fingertips.
Doc, while we're on the intracellular topic, I have something to relay from Tricity in the chat. She's curious. I'm sorry, Tricity, I'm going to come back to yours, but Romero had one asking, does the virus attack only certain type of cells in our body?
Yeah.
Well, it seems, so the question is certain types of cells. It has to find receptors. So we get these viruses in our body occasionally from the animal sources, and most of the time the mutation can't find a binding site and it just dies out and never replicates. With millions and millions and millions of different mutations, one like this will occasionally find a binding site. The binding site it seems to have found, maybe the ACE2 site, is mainly in the lung tissue. Now, it does go through the GI tract. We found virus in the gut, and which is why some people develop diarrhea with it. But it doesn't seem to be a serious invasion as it is in the lung. So mostly those goblet cells and the ciliated cells in the lung. It doesn't attack everywhere in the body. There has been one ophthalmology report about conjunctivitis, meaning the virus got in the eye and caused not serious inflammation in the eye. But that's just a couple of reports.
Great. I've also got one from my own circle, from an MD in my extended family, saying when it comes to zinc, you want zinc picolinate or zinc acetate, probably not zinc glutamate, which is the most common. Is that borne out by what you've heard?
Yes. So I don't think it's zinc acetate that they're using.
Okay.
And again, should you take zinc orally? Does it help? According to the fluorescent studies, not much zinc gets into the cells. According to the studies, there was a big study out of Tel Aviv, people that took zinc with influenza compared to people that didn't seemed to do a little bit better. The latest meta-analysis that I saw in PubMed looking at oral zinc in general without the chloroquine is very, very mixed. There's an equal number of yes and no good studies. So we don't know. I will tell you again up front, working where I work, I take zinc every day. And I may take a little bit more during this epidemic.
The guidance I've heard is the first 24 hours after symptom onset is the time you want that.
Yes. So what I found anecdotally is as far as treating colds, if you take it as soon as you're getting sick, it may head it off. If you wait till, oh, damn, I've got a cold and this is a sure thing, I don't think it works that well. It just can't overwhelm the virus. So when I get sick, I take it 3 or 4 times a day, just like vitamin C, which is probably worthless. When you take enough, it'll give you cramps and diarrhea. But for prevention, I take zinc every day. There's no downside other than the cost of the zinc, and it might help. Did my intranasal zinc really work? I don't know. I will tell you, it burns the hell out of your nose. And the other side of that is there are some case reports of intranasal zinc causing destruction to the olfactory receptors and people losing their smell, either short-term or permanently. So it's not without risk.
Yeah, I will just add that is a known way to permanently remove olfactory bulb cells in animal models, people studying anosmia. Don't shove zinc up your nose.
Yes. So fortunately, I will say after doing that, I still smell.
I also have a social distancing question from Tricity in the chat. Is now a good time for that?
Sure.
She asks, and I've heard this each way in my own consumption of media lately too, so I was curious about the same thing. Some sources are saying more than 1 meter. Some sources are saying 2 meters. What's the bubble we want to give ourselves?
I would use 6 feet.
Okay.
Can you translate to meters?
Well, I mean, 6 feet's about 2 meters.
Yeah.
Okay.
So about 2 meters is, we don't know for sure, but I would say about 2 meters.
How long do you anticipate that we'll need to keep doing that?
Again, big unknown.
Okay.
Because people can be asymptomatic, so we don't know. And how long will it take us to get our, shit together here, to test enough people and to isolate enough people? We're not taking the steps that they have taken in Korea and China of taking people away from their families. We're letting people stay in their homes, if voluntarily, and then they can infect their whole family, and then that can spread outward. Right now, I am telling people if they test positive to isolate for 2 weeks.
Wow.
Okay.
Yes, I know that's a lot to ask people, which is, major trauma. But, we missed the moment to step up when we had the chance in this country. And now we're playing catch up.
Actually, the WHO has a very interesting, clear direction sheet for dealing with infected and possibly infected people that are sick. they have these pages. I can share the link later in the chat. They have this in every language probably available, but one of the clear things is that if you have one person sick like this in your house, you put them in a separate room, among other things. They have very clear, simple to follow directions for that.
Well, what I've always told people with influenza, if only one person is sick, that person needs to wear a face mask when they're around everyone. So again, the face mask, surgical mask is what we're talking about, that goes over the ears. Won't protect you from other people. It does not filter out the virus, but it'll protect other people from you. Our ID people have told us, once you put a face mask on a patient, then you're good to go into the room with them. So I tell them either wear a face mask around everyone or go into a room by yourself until you are fever-free for 24 hours without fever medication. And with the flu, that's usually about 5 days to a week. Here we're talking about 2 weeks, which is a little harder for people to do. But in places where they've done that, their new case rates are coming down. They're flattening the curve. So we talked about flattening the curve, and you've probably heard this. And why are we taking these draconian steps to do that? Is it to eliminate the virus? I think it's too late for that. That's not going to happen. What we want to do with the social isolation is reduce the rate of increase in cases so our capacity to care for people doesn't get overwhelmed like they had happened in Italy. So if you don't do anything, your case rate goes up like this. Here is your capacity, ICU beds, respirators, healthcare people, and you'll quickly overwhelm that. And you'll have a case of people who need an ICU bed being treated in hallways of hospitals, and our death rate will go up. What we want to do is try to flatten the curve, because probably what will happen is eventually everyone will get this. And by flattening the curve, it will take longer to the world and infect everyone, but we won't overwhelm our capacity to take care of it. And that's what we're trying to do. We don't want our hospitals to fill up. Right now, I don't think anyone is in an ICU bed in this area, fortunately. So we're still good. But if we move this way, that could change quickly. So since we're a skeptic group, scams and quacks, I'll go through this rather quickly. And there are a lot to go into. I will say overall, alternative scam medicine is having a great day. Acupuncturists can't make enough appointments for people. Chinese traditional medicine selling out everywhere.
Before we dive on this, can I squeeze another one in from Ramiro in the chat?
Yeah.
He says he's heard the UK is trying the herd immunity approach. Anything about that you can speak to?
What does he mean by that?
Ramiro?
I just heard that they want to infect as many people as possible, so that they
like with chicken pox.
Sort of, yeah.
That's probably not a good idea. I haven't heard that.
And normally you would
do the opposite of this.
Yeah.
Then you get more people infected right away, and your capacity gets overwhelmed.
So I think because I heard that the reasoning is that the more people that become immune, it's kind of like vaccinating everyone. But I haven't heard a good good reasoning for why doing that. I just don't know if the sites that I've been reading are giving me bad information about how the UK is dealing with it.
Yeah, I hadn't heard that, Ramiro. I haven't read that anywhere. This came out of Boris Johnson. I don't.
Right. Well, that sounds completely bogus, Ramiro, because one, we don't know if people are immune after having gotten and recovered.
Exactly.
And two, herd immunity would normally refer to non-disease producing immunization, like a vaccine. So I think that source is confused.
Yeah,
But yeah, I was more curious about whether they are really doing that in the UK or not.
well, I haven't heard anything about it.
Okay.
And if they did, I would be really surprised.
Yeah.
So scams and quacks. These are just some of them. This is one of my favorites. This has been sold before coronavirus, but is now claiming to be a method of defense against coronavirus. It is a strip of copper, sort of shaped like a thermometer, and you insert this in your nose. The theory is that there are reports of copper in laboratory killing off virus. We do know that viruses don't last as long on copper surfaces as regular surfaces. So there's validity to the theory in the lab. The problem is there are no studies and no clinical trials. Does putting something that's copper in your nose do anything to kill off the virus? Kind of like me shoving zinc up my nose.
No.
There are more studies. There are more studies with the zinc in the nose.
Yeah.
We don't know, does putting copper in your nose actually work? So for this online, you pay about $60, $70 for about $2.50 worth of copper. You can see the quotes. There are all these quotes online. This is the inventor, Dr. Doug Cornell, PhD, who says 7 years without a cold. Dr. Doug Cornell, PhD, has his degree in social psychology. So if you want to spend $70 on a piece of zinc or put pennies up your nose, I wouldn't recommend the pennies. I spend enough time taking pennies and things out of people's noses. This comes from the chiropractors. How to catch the coronavirus and what can you do? And there's all good advice in here. This is a handout that is made available to chiropractors to hand out. And on the bottom is skip your chiropractic adjustment. And you'll get coronavirus. What they're claiming is upper cervical chiropractic adjustments will boost your immune system and protect you against coronavirus. So that's the pitch. And here's a bunch of things that I found online. These are a lot of places that the FDA has been going after for making false claims. There's a spine center in Charlotte, thank you, who said, be safe from the coronavirus by boosting your immune system with chiropractic care. No, there's no evidence of that. This is another one, I think in New Mexico. They cite an unpublished 4-page paper from 1978 full of uncredited statistics and anecdotes that claim that people during the Spanish flu epidemic that received chiropractic care did better in the epidemic. There's
Actually, no, wait, Doc. It says they died at a much. Oh, I thought it said slower rate. Sorry.
Lower rate with a lot of neck pain. They died at a lower rate. So, I don't know where they got that from. And they're also selling a lot of herbs and herbal preparations. This is another health center that shows a potent mixture of echinacea premium that they swear will boost your immune system and protect you. I've never seen any good studies that show echinacea does anything. I put that down with vitamin C and.
Anecdotally, it makes me smell a little bit gamey when I've taken it.
That's a good reason to use it. So the FDA is going after a lot
Good for social distancing.
These are all companies that have been advertising cures. Here's some colloidal silver. I went to each of these websites and all of them have either taken it off because the FDA went after them or changed it. There's one that added a disclaimer, nothing in this claims to treat anything medical or any medical condition, blah, 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 blah. And several of them, I think Herbal Amy has completely taken everything off her website. And one of the big ones is, there's our friend, Jim Baker.
Oh my
Jim
God.
John's Tammy, yeah, there you go, has been pushing silver colloidal solution. I don't know if it's blessed by Jesus or not, but specifically to treat or cure or prevent coronavirus. He was sent, FDA went after him hard and fined and has, I think, taken that offline. Other things going around that I've seen online over the last couple of weeks, coronavirus has been cooked up by a secret government lab in China. That's a popular one. People are actually looking into it and looking at the genome and looking at what's going on, and there is no evidence right now from multiple investigative sources that this was cooked up in any lab anywhere. There was one about Bill Gates behind the spread of the virus. I'm not sure why, but not true. China might be introducing it into Taiwan to help control and take back Taiwan. Not true. And here's one that I found. Even what you probably just read that.
Yeah.
My neighbors quoted this, that toilet paper comes from China and the supply is going to be cut off, which is why my neighbors are storing up, I don't know, years worth of toilet paper. Either that or they all have diarrhea as a side effect. And also one that toilet paper is infected by the coronavirus. So our paper comes from here and Canada, not from China. There's no shortage, except people are grabbing it off the shelves and hoarding it faster than people can buy it. And it's not infected. WHO, and this is one of the links you can click on, actually had to put up a Mythbuster page specifically for COVID, and I think CDC has one, and Snopes has one specifically to address stuff about COVID. So this is COVID can be transmitted in areas of hot and cold climates, so that's not true. Cold weather and snow cannot kill the new virus. These are true statements. Taking a hot bath doesn't prevent the disease. Coronavirus cannot be transmitted through mosquito bites. Hand dryers are not effective in killing the new coronavirus, hence paper towels. Ultraviolet light may kill it, but the amount of ultraviolet light C that you would use if you were to expose your body or your hand to it would not be good. So just don't do it. Spraying alcohol or chlorine all over your body will not kill the virus that has already entered your body. Regularly rinsing the nose with saline will not prevent the infection. Eating garlic will not prevent the infection. And there are no specific medicines recommended to prevent it yet. So this is what WHO has had to do over the last few weeks because of all the misinformation going out. The other thing that's going out is scammers have been calling people claiming to be from WHO, from WHO, and they're trying to get people to give them their information. Give me your phone number, your credit card number, the information so we can hook you into this, or asking for contributions to their relief organization. So they had to send this out saying, nobody from WHO, just like the IRS, will ask for your username or password or email attachments to click on or any other links, or tell you to send them money to register for a conference or win lotteries or prizes. But all these scams are going on right now, trying to make money off of this. And I was in my Publix trying to get groceries, and I just happened to see these. I was tempted to buy it to read the article, but I just couldn't bring myself to give them any money. So you see, we found a vaccine to save your life. Coronavirus destroying the world. And then in the Inquirer, miracle pill and kitchen treatments that work. Coronavirus cures finally found. So I guess people will buy anything. So what does the future look like? We don't know. Will it peter out with the warmer weather? Maybe. Will it move to the southern hemisphere just like flu and move back and forth each season, eventually maybe mutate to a milder form? I don't know. There are already cases in Australia where it's summer. Most likely we'll all end up getting some form of this, and and it will probably mutate to a milder form. The only reason I say that is it's to the virus's advantage to do that. Not that it can make a decision to do that, but if you don't kill your host, you have a host to replicate virus. If you kill your hosts quickly, you don't have a chance to reproduce and move on. So genetically, it's in its advantage to become milder. As the virus spreads and we develop antibodies, the virus will run out of naive hosts. That's people who have never seen the virus before. And we will get vaccines and antiviral treatments that should help. So,
Got a question from Michael in the chat.
yeah.
Might ozone kill the virus on surfaces or instruments?
Will what?
Ozone?
Ozone? I don't know the answer to that. I mean, we use ultraviolet to sterilize equipments. I've even seen a nice little device that you can put around your cell phone and it'll release ultraviolet light on your cell phone to sterilize it. It might work, but don't use it on your body.
Right.
And so, Mike, I don't know the answer about ozone. If you find out, email me. So basically, one of the last slides, be safe, be wise, stay informed, be kind to each other, and don't panic. And then the final slide, whoops, the final slide just has links in it. So I took a lot of the, boy, that's a lot of slides. I took a lot of the sources and I put them in a page of links.
And Joel,
Yep.
we're going to put the slide deck up on foreversexual.com, which is our website that we already have up.
Right, that's our website. So foreversexual.com will have it. I think, Jeff, you're going to make it available.
Yep, it's on Scribd and the link is already in the chat for anybody who wants to grab it. I'll put it on Facebook and meet up in the notes for this event too.
As you can see, these are all hyperlinks of good sites with useful information and neat graphs. There's Snopes COVID page, WHO's Mythbuster page, the North Carolina Department of Health, the CDC.gov. So there are a lot of good sites to go to. Jeff, you sent me one link that I think is in one of the slides here from Johns Hopkins, which has that genotype and a good evolving map of infection. Worldometer here is a good site to go to. That's where I got a lot of my up-to-date information. This is the Johns Hopkins site.
Doc, I'm sorry to interrupt. I'm going to have to go, unfortunately, but I want to say, wow, thank you. That was excellent, and you are an excellent presenter. I know several people who would really like to see and benefit from this talk. So can't thank you enough, man. That was great.
Thank you, Eric.
Oh, no problem. Thank you.
Okay.
Sorry to have to go.
I know. Stay safe.
Thank you. Bye, everybody.
This is the Johns Hopkins site, one of my favorites that gives you a lot of data right at hand. So you can download the slides, you can click on those links, they're hyperlinks, they'll take you to all those pages.
Great.
Okay.
I'm going to relay one from Eric that he dropped in before he had to go, which is, will rubbing Vaseline inside your nose provide a viral barrier?
Yeah, not that I'm aware of. Putting corks in your nose, I don't I'm not aware of any data on that. We know that saline spray in the nose doesn't really help it. Although when your mucous membranes dry out, they don't defend against invasion as well. You want to keep them warm and a little moist, but saline spray doesn't seem to work. Yeah, wash your hands.
What is the testing availability like in North Carolina?
Very good question, and that changes from day to day. We are just getting kits out. I can speak for Duke. I can't speak for the other health system. We just had another daily meeting. We have now set up drive-up centers in several of our urgent care centers. So just like in Hong Kong and Korea, you can drive up and get tested. We can't yet, we don't have enough kits to test anyone who wants to be tested. I would love if we could do that, but we just don't have the number of tests yet. We're running out of tests, we're running out of swabs. If you have symptoms, if you have a known contact, you can probably get tested, but if you're asymptomatic and don't have a known contact and just want to get tested, right now I don't think anyone will test you around here. We're getting more tests each day, but we're running out as quickly as we're getting them. So we have a protocol of when we can test, and that changes almost daily. But you can. I would say if you think you have symptoms, or if you think you've had a contact, you can call. Most of the medical centers, including UNC, I think WakeMed and Duke, we all have telemedicine sites that are ramping up. You can call or go to the website and get a link. You can go to the telemedicine and they can tell you if you need to come in to be tested or where to go. Definitely if you have symptoms, and if the symptoms are more severe, if you can wait, you'll probably be sent to the ER, but we need to let EMS and the ER know what they're dealing with so they can take the precaution before you walk in. So to answer your question, testing is better today than it was yesterday. Today we have drive-up centers. People are swabbing people in their cars. We're not swabbing children only because it's difficult to do that on a drive-up. There's nobody, you can't hold down the child and try to swab their nose. If you've ever tried to swab a child's nose for flu, it's not a lot of fun without contaminating yourself. So right now we're testing adults within the testing criteria, but don't just go in because a lot of people get disappointed and sometimes angry when they find out they can't be tested yet.
Okay. How would you, so I have allergies, and obviously now every time I have a tickle, I'm like, oh no, it's like, this is what it is. How would you kind of, obviously I'm panicking a little, which you also said not to do. How would you kind of temper that kind of, is it allergies? Is it coronavirus?
It's a good question. So I have a chronic cough from postnasal drainage. So I clear my throat and I cough many times a day. But I know what my cough is like. So definitely if you're running a fever, and we're defining that as 100.5, there's discussion about where that level should be set, but it's 100.5 for this. We're not going by, oh, my normal temperature is 96, and if I run 99, I have a fever. We're going by the 100.5. So if you have a fever, definitely if you're short of breath, definitely if it's a new severe cough, or any combination of those. And add to that, if you know you've been in a high-risk area or in close contact with someone that is known to be infected. So don't panic, but call. Our telemedicine, we are recruiting more and more volunteers to work our telemedicine center. These are mostly PAs and MPs. So we're trying, I mean, UNC, I know UNC, WakeMed, and Duke had been starting telemedicine way before this, with the idea of ramping it up over the next year. But now we are going into hyperdrive, trying to ramp this up so that that's available for everyone. So fever, significant fever, feeling crappy, bad cough, and particularly short of breath.
Okay.
Anyone else?
I have another.
Yeah, go ahead.
You said to kind of treat every surface as if it has the virus.
That's what I do.
If I'm at home and neither me nor my fiance, who I live with, have any symptoms, should we be doing the same thing in our home as like every surface could possibly infected. Like we weren't planning on like licking the table or anything, but I'm like how I'm about to wash my hands too much.
So again, we do know that the rate of infection and symptoms are probably dependent on the viral load that you get exposed to, meaning that you pick up a couple of viral particles on your hands, you're probably not going to get infected. But if you put your hands down where someone just sneezed, you probably are, or in an area for a prolonged time. So I live with my partner Bonnie. We're both in our early 70s. Both have other illnesses, chronic illnesses. So we're trying to be careful. And we haven't been around anyone sick yet that we know of, but we just try not to touch our face and hands, and we wash a lot at home.
Okay.
So I would just, you can't wash your hands too much. Wash your hands. If I go out, I definitely do. And I am shocked that there's a rate on toilet paper, but I still see most people going into shop and not wiping down the handle of their shopping cart. I used to be the only one that did that used those little Purell wipes. But now I'm seeing some, but there's still at least half of the people are going into Costco, going into Publix. They are not wiping down the carts. They're not wiping down their hands afterward.
So, Joel, it was interesting today when I was in Publix, there was one of the people from Publix standing there wiping down the carts and handing them to you.
Yeah, that's excellent.
I experienced that at Costco a couple weeks ago, actually, when this thing first started to blow up.
Yeah, Costco, I think, had wipes at both sides of the entrance, but nobody was handing it to anybody. But yeah, I would wipe my hand. Occasionally what I would notice is as I'm wiping it and looking at someone else, they look at me and then they wipe down their cart. It's kind of like, when do you wash your hands in the men's room? Well, if there's someone else in the men's room looking at you, you wash your hands. That's reality. Good. Any other questions?
Yeah, hello?
Yeah.
I was just wondering, I did the chat, but so let's say you catch it and you're getting a lot of congestion. Maybe you're doing okay. You're hopefully not going to need to go to the hospital, but you're having a lot of heavy trouble breathing. I mean, I remember having like a bronchial pneumonia and just being out in the country and not having anywhere to go with it, and just it was like every breath was a little precarious.
Yeah.
And I was wondering, and there was all kinds of things marketed, of course, to, break it up, or nettles and all kinds of stuff. And I couldn't get any real medicine even though I had tried. But is there a recommendation for, you're having a lot of phlegm, the typical thing, and you're thinking too much? What's the recommended thing to do there?
So what I tell people normally without COVID, if you're just talking about a lot of mucus in your upper respiratory tract, it's mostly in your bronchioles and nasal passages. I say get in the hot shower. And that hot
I know that
will reduce the sulfur tension and break things up. I don't use Mucinex or guafenicin, and I don't use any of those things. I don't think they really accomplish that much. You could, there's no downside, but you could use it. The other thing that I do when people get chronic mucus production and a post-viral dry cough that a lot of people get is I will start them on glucocorticoids like Flonase. I use that. Short-term, anticholinergic like Atrovent, which side effect is it dries out mucous membranes. It won't get the mucus out of your lungs, but it'll stop the constant drainage. So I would say, as far as symptoms, if your symptoms are mild, especially if you're not running a fever, if your symptoms are mild, treat it the way you normally would treat it. If it's more than that, you need to get in contact with a provider. And I recommend telemedicine if you can access it. I know Duke has dropped the fee for telemedicine to like $20, and they may drop it further, just so that you can have easy access to it. Some insurance will cover it. A lot of insurance companies are even starting their own telemedicine sites. but treat it, so if it's mild, treat it symptomatically. If you think it's more than that and you're having trouble breathing, then I would call and see what they want to do. For mild symptoms, we're just telling people to stay at home and treat the symptoms and call us back if and when it gets worse. We just have to do that right now.
Oh, would you happen to know, I had a vaccine 2 weeks ago, I think right about 2 weeks ago now, for the pneumonia vaccine.
The Pneumovax?
Yeah, I
Good
had
for
a
you.
pneumovac, and I think I'm sensitive to strep. Could I be experiencing, a slight version of it post-vaccine?
You can get, there are a few cases reported of just a vaccine reaction, like people get from influenza vaccine, where you feel a little feverish and a little achy, but you can't get the disease from the vaccine
Right,
because it's not whole activated
right,
particles. The pneumonia vaccine only protects you against pneumococcal pneumonia. It doesn't protect against other types of pneumonia,
right.
and which is a bad pneumonia to get. And you said you had strep?
Well, I was actually, what my experience was, maybe a little bit ties in today. So I was having just a little bit of sore throat, and I was wondering, it'd be kind of cool to rule out strep. But then I was thinking, oh, it kind of is coming and going. I didn't want to expose myself to. I go to Duke Primary Care over in Creedmoor Road, and they had lots of appointments, by the way.
I would say
I
for
didn't
strep,
know.
a couple of things about strep. If you're not running a fever, it is less likely to be strep. If you have a runny nose and cold symptoms, it's less likely to be strep. And the truth about strep throat and antibiotics is that most of us that are healthy are going to get over it in about 5 to 7 days. And with the antibiotic, we're going to get over it maybe 24 hours earlier. It doesn't necessarily prevent the rare complications of strep kidney and strep in the heart.
Yeah.
So the antibiotics, I don't think I wouldn't risk my life going in and getting infected with COVID
I changed
just
my
because I
mind.
was worried that I might have a strep throat.
Maybe I should go. Yeah, well, it sort of comes and goes, and it was like I was
Yeah.
having a little more this
But
morning. I called and mentioned.
telemedicine is an option for you.
But no, everything's fine. I think so.
Good.
Is asthma, I've seen kind of conflicting things about if asthma is a risk factor or can make it worse.
I would consider it a risk factor.
Okay.
Especially more severe asthma. Smoking seems to be, in China, I think they found, and Korea, smokers were at higher risk, and I think Italy is finding the same thing.
Okay.
So age is a risk, independent of disease. Comorbidities, definitely diabetes, severe heart disease, and smoking is somewhat of a risk. All of those don't help.
Okay.
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 We good, Jeff?
I think we're pretty good. Does anybody else have anything to add before we wrap up the featured presentation?
I'll just mention. I don't know if this is rude to mention, but I think this is a great interface. So I threw on the 30s, 40s, 50s meetup just a discussion to further discuss this kind of thing or whatever things are on people's mind on Sunday, if anyone wants to look for it.
Great. And just so you know, Wendelin, I'm gathering everything from the chat, including your link, and I'm going to post that as a sort of addendum in both the meetup event and the Facebook event.
Great. The only thing is, maybe you guys can help me because when I went to schedule, how it's like, I volunteered doing some of this stuff a long time ago on Zoom, and I couldn't figure out even how to do a 40 minutes, like 30 minutes where you go over your free time. So I posted two like IDs. So I guess, I don't know, because this is great. Did you guys pay for this or you have some kind of
I did pay to upgrade my Zoom account so that we wouldn't hit the time limit. Yeah.
Okay.
I figure I'm going to use it for this and a number of other things in my personal life, so it's worth it for a few months.
Okay. So I heard that you can kind of just kitty corner them.
There's always a loophole, right? Yeah.
But we'll see if it goes great and people want to do more. We, could do more with it as a group or whatever.
Yep.
We'll see how it goes.
I think it's an interesting platform.
Yeah.
We're thinking of using this. We teach senior sexual education, and the senior centers are closed. We're thinking of using this to continue our classes.
Cool. There was a thing on NPR like a couple of years ago that goes, one of these cool little tidbit, little gems on NPR saying in New York or a borough of New York, they had this program for senior citizens. Maybe they had to qualify for it, but they had, and people volunteers, and I just volunteered to do a presentation. So basically you could, you go on and you'd be a member of this thing, and there was this huge, very enriched calendar of all kinds of, presentations and discussions and so forth, all across all walks of life, and that you could just kind of sign up for any one of them if you kind of qualified. And it was a way for people to socialize and get connected who maybe had mobility issues or whatever. I thought that was amazing. I was fascinated by this, and I jumped right on the bandwagon and wanted to see what was it. Because I'm like, who wants to drive? I mean, sometimes I just rather go to a Zoom thing. I'd rather do this on Zoom half the time than drive across the triangle or to sit at the end of a table behind some guy, whatever. It might not even be good.
Yep.
So this is no risk, It's always,
a great platform.
This is great. I love this.
So I'm going to take a moment to give a shout out. I see Mac and Joan online. If you're still online, just to say hi. Some friends of ours from California.
Hi, Mac and Joan in California.
I don't know if Amy or our friend Jackie from Toronto made it on, but I'll say hi.
Yes, Jackie is on, and I think
Jackie?
Amy is on.
What's that?
I think Amy is on, and I think Jackie. I did see Jackie.
Hey, Jackie. Hi, Amy.
I see a call in from 610 area code. That may be BC. I'm not sure.
Yeah, could be. Yeah, Amy is on. She just sent me a message that said hi, and Jackie said hi on Messenger. So that's
nobody from British Columbia, though.
Yeah, no one from British Columbia. Jackie is up near Toronto.
Ontario.
Kitchener, yep. Yeah. I'm glad you all could make it.
Yeah, thank you everybody for coming tonight. It's great to see so many new faces and new voices. Well, to hear the voices if we didn't see the faces. I want to encourage everybody who found us via Facebook to throw a like on the Triangle Skeptics page. We need them right now as we're in the growth phase. I hate Facebook more than anybody, but we need the likes there because it's one of the ways that we can grow. Okay. If you found us via an outside angle as opposed to Facebook or Meetup, consider joining Triangle Skeptics on one of those channels, please. We're, again, trying to grow the group, and we'll soon have like all the nonprofit infrastructure in place to have actual memberships for people who are interested in having a membership that actually supports the group financially. So stay tuned for that stuff.
Cool. And Jeff, you're going to make the slides and the recording available. How?
Yes, the slides are on Scribd already. I put a link in the Zoom chat for those things. I'm also going to post a comment on both the Facebook event and the Meetup event that has essentially a dump of the chat contents, and that has a link to the slides as well.
And the recording? And the recording.
I haven't dealt with a Zoom recording yet, so I don't know exactly what form that's going to take, but maybe it'll end up on YouTube. Maybe it'll end up in some other place.
The uncharted territory.
But I'll provide a link to it. Exactly.
All right. So, we done?
I think so, unless somebody has a magic trick.
I would have. I didn't know you'd ask.
We're always seeking magic tricks.
I could have done a magic trick.
I can make people disappear by clicking.
By clicking this button right here.
Okay, thank you, everybody. Thank you so much.
Thanks, everybody.
All right.
Be safe, be healthy.
Good night, all.
Careful.
Live long and prosper.
Thanks. Pleasure.
Thanks, everybody. Good night.
Right.
Good night.
Good night.